In this problem, we're just finding delta H in a different way. So before we were given the delta H's for each step of a reaction. And in this case, we're using the standard enthalpies for each individual piece of the reaction. We see the chart down below. So essentially it's saying it's the sum of all the enthalpies of each individual component. So all that energy is locked up in the bonds. So that energy associated with it in kilojoules per mole is associated with breaking bonds and making bonds. And so that's where those energies come from. So if you're asked to do this, you're always going to be given a list of the standard enthalpies for each piece. And notice it's always the products minus the reactant. So let's go through here and solve for this one since we have all the pieces. So the delta H, and that's just the formation of it for the reaction, is equal to the products minus the reactants. In this case, I have 6 CO2s plus 6 H2Os, products minus the reactants. We have C6H12O6 plus our 6O2. If that reaction looks pretty familiar to us, look at it backwards. Yeah, it's just photosynthesis, right? CO2 plus H2O gives us glucose and oxygen. And really, this is your body using glucose plus the oxygen you breathe in. We produce CO2 and H2O. So it's just the opposite. So I'm just going to plug numbers in now. So I'm going to do my 6 times from down here. Our CO2 was negative 393.5 plus from there 6 times negative 285.8, and then minus our glucose there. 6 times negative 1275.0 plus, and here's the only trick to this. Anything, it said anything in its standard state. So anything that's an element or a diatomic element, because oxygen is always going to be paired with another oxygen. So an element by itself or a diatomic element is 0. Essentially, we're saying there's not bonds to be broken there. We're not going to break up that O2. There's no real energy associated with it because it does it on its own. So plus 0 in there. So plug that into your calculator. Be very careful how you calculate. There's a lot of parentheses in there. And you should come up with the overall delta H for this reaction of negative 2800.8, and that's kilojoules per mole of reactant.